Hey guys, so we're moving on to another section in linear functions. And today's lesson is going to be focused primarily on if you're looking at the graph of a line and knowing whether a certain equation matches that graph or not. Okay, so this sort of involves you having watched the other videos, knowing y equals mx plus b. Also helpful to know how to find x and y intercepts by setting x and y values to 0. So if that doesn't sound familiar, you probably should watch the other videos first before you jump into this one. Okay, so where are we here? So let's take a look at our graphs here first. I'm just going to copy a grid from the previous diagram. So let's see if I can copy that. See if that works. Control C. Not sure if I highlighted that or not. Control V. There we go. Perfect. Okay. And then I'll sort of move that grid around here. Okay. So let's take a look at a few different equations. Where are we? There we go. Perfect. Okay. So I'm going to switch over there, turn my video off. Perfect. Okay, so let's say you're given the following equations. So y equals negative 2x plus 4, y equals 4x plus 4, and y equals 2x plus 4. Now, if you've done all the homework from the previous units, you might actually, in a sense, start to get a sense of what these lines actually look like just by the way I've written the equations. But maybe it's still a little bit new and it's just not quite clicking for you yet on how to draw these pictures. And let's say we draw a sketch for you, and so we put a dot at. Let me see if I can get some. These are different colors. Use green's kind of nice. Okay. And we'll put a line to point over here and draw a line through those 2 points. And the question is, of the three functions I wrote above, which one is this green line? So is it the first one? Is it the second one? Or is it the third one? Okay. And there's a couple different ways to do this. One is technically you could draw all 3 of those lines to see which one matches. But another test that we do, which is quite useful in other areas where we're looking at graphs, so in higher grades for yourself, is we test 2 points. Now, the reason we test 2 points for a line is that it might just by chance that you guess one of the points right, but the other point's not right. So it's possible, like for example, if you said this point is on a line, right? But it could also be on that line, or this line, or that line, or this line, or this line, or that line. There's many different lines that would go through that one point. But if you have 2 points, and the line goes through those 2 points, then those 2 points would have to be on that line. There's no other line you could draw that would go through both those points and still be a line. Now, I guess you say a straight line, a linear function. So for example, a circle can go through 2 points that aren't in a line, of course, but we're looking at straight lines in this chapter. So I'm going to pick 2 points, and I'm going to test them. I'm going to plug them in and see if they make sense. So I'm going to pick the x-intercepts because they're very easy to see. Sometimes you can't see them very well. Like for example, if the line was to go through like that, I wouldn't want to use the y-intercept there because that'd be too hard to see. But clearly I can see that very easily, and I can see this point very easily here. So I'm going to test, let's call this point A. Let's call this point B. Okay, so I'm going to test point A in the first equation. Okay, so I'm going to write the first equation, and remember the point now, that point is a y-intercept, so it's 0, comma, whatever the y value is there, which is 4. So I'm going to test that point in the first equation. Now don't forget, when you write a point, it's x, comma, y. So this would be 4 is equal to negative 2 times 0 plus 4. And that would be 4 equals 4. and that's true. Okay, so that would be correct. So we know that that point and that line must cross each other. That line has to go through the point A. So we know that much, okay? Now if we plug it into equation 2, so now I'm going to do the same thing but equation number 2. So now I have 4 equals 4 times 0 plus 4. So I get 4 equals 4 again. So once again, that's true, which means that line also goes through point A. So there's 2 lines that go through point A. And if I look at equation 3, I put in that into that equation. So 4 equals 2 times 0 plus 4. And once again, 4 equals 4. So really, that, I guess, tells me that point A is on all 3 lines. But if I pick a second point, then there's no way these 3 equations can go through 2 points unless they're the same equation. These equations look quite different to me. So now I'm going to use point B here. Okay, and point B is an x-intercept, so I know the y value is 0 at an x-intercept. That's the rule. And I know that I'm plugging in -2 for the x value. So if I plug that into equation 1, I would get 0, because that's the y value, equals -2 times -2 plus 4. So I get 0 equals, now a negative times a negative is a positive, so I get 4 plus 4, and I get 0 equals 8. And I'm sad, okay, because I know 0 does not equal 8. That would be redonkulous, so that is incorrect. So what does that tell me? Well, that tells me that the point A is on equation 1, but point B is not on equation 1. So that would be something that would lead me to believe that line 1 does not go through these 2 points. Okay, there's other factors that you might have already realized about that line, but I'm just trying to show you this one technique of testing points here, and this is used quite a bit in other math courses and chapters. Okay, so let's try equation 2. So I'm going to make a y value of 0 again. I'm going to plug in 4 times -2 plus 4. And so I know that's 0 equals, that's -8 plus 4, and 0 equals -4. Once again, that would be incorrect. So that point B, that is, cannot be on equation number 2. Okay, so let's try our last point. And that would be plugging it into equation 3. So 0 is equal to 2 times -2 plus 4. So 0 is equal to -4 plus 4. And 0 would equal 0, which that is actually true. That's a true statement, right? So the only line that passes through both points A and B would be this one. That's where I get the two true statements here. So what that means is the equation number 3, y equals 2x plus 4, is the line that passes through points A and B, the only line that passes through points A and B are the ones given. So now you can imagine if I rearrange the equation into that other form where it's like 2x plus y plus a number, that might be harder for you to sort of see. And what I mean by that is that what we should have probably realized just by looking at all these check marks in the beginning here, these 3 check marks right here, is that notice that the y-intercept is 4 in all cases. You remember our formula, y equals mx plus b. The 4 is the y-intercept. So you might have already realized that A would have to be true for all 3 lines. So maybe you only have to test 1 point then, if you sort of know those kind of tricks. The other thing you might realize is this slope is positive, it's going up. So we know it can't be 1 because 1 has a negative slope. That would be going down. So that's other clues you can look for. So once again, you see the negative sign here. That negative sign tells you the slope should be going downhill. And the other 2 have positive numbers, so they should be going uphill. And I guess the last clue you could have done, because it's in slope-intercept form, is if you knew the m value is the slope, then you could just look at the slope and say, well, it's gone up 4 and over 2. So 4 over 2 is 2. So there's lots of different ways to sort of prove these, but what I'm trying to drive at in this lesson is the idea of testing 2 points, and the concept being that if a line passes through 2 points, then there's only one line that would actually do that because it has to move through those 2 points. And if you really weren't sure, you could test a third point on the line. And what I was going to say about that is make sure you pick something you can easily see that it goes through. So for example, I'm gonna circle this point right here. See right there? That blue place, that's a really difficult value to approximate. So I would never pick something that's not really clear for me. So right now, though, I'm going to put a dot here. That point right there, which would be 1, 2, 3, 4. That'd be -4, comma 1, 2, 3, 4. So -4, comma -4. So if I really was not sure, I could do one more test. And let's just test the third equation again, because I know the other two don't work. And so I'd say -4 is equal to 2 times -4 plus 4. So that would be -4 is equal to -8 plus 4. So -4 is equal to -4. That's true. So you could test like an infinite number of points if you really wanted to, but I think if you test 2 points, at least for straight lines, then you'd have to know you're right at that point. So we can see in our example here, that first point was okay, that was okie dokie, but this point down here was not so okie dokie, which means that equation number 1 cannot pass through those 2 points. Okay, so I've kind of beat that into the ground. Okay, so let's take a look at another equation then, where maybe it's we can sort of C control V. There we go. And so I'm going to draw 3 lines on this graph. Okay, 3 lines on this graph. And let's see if I get them right first of all. So 1, 2. So I'll draw a black line here. Pretty close, I guess. Okay, so we draw that one. I'll draw a green line. See? Kind of like that. Should probably put ends on my line, so because it goes on forever, so it's kind of important to show that. And then I'll draw a purple line because purple's a cool color. And let's see here. 1, 2, 4, 7. Yeah, okay. So 1, 2, 3, 4. Okay, so there we go. So there's our 3 lines, right? Feels like a Monty Python skit. And the question now is, if you were given the equation x minus 2y equals -4 equals -4, could you use this technique we just showed you to determine whether 1, 2, or 3, or maybe none of them, are actually this red equation here, okay? So once again, you could rearrange it, put it in a slope-intercept form. That's definitely a valid way to do this, but once again, I'm just trying to drive home the idea of testing points here, okay? So I'm guessing, since they all go through a y-intercept at the same place, that this equation probably has a y-intercept of 2. But let's just test that. Let's pick that point. I'll call that point, let's call it A. And the y-intercept here is at 0, 2. So that's A right there, okay? So I'm pretty sure that's going to have to be true. Otherwise, none of these equations are going to be correct here. So don't forget the 0 is the x and the 2 is the y. So I've got 0 minus 2 times 2 is equal to -4. Of course, that's -4 equals -4. And so that kind of verifies what we probably sort of already knew here, okay? So now what I would do is maybe I try to plug in these other points here and see what we think about that. So let's plug in number 1 first. I'll just do number 1 first, and I'm going to plug in point B, and that point is the x-intercept here. So with number 1, I'm going to plug in 1, whoopsie, and I'm going to plug in point B, which is -4, comma 0. Oh, sorry, it's equation. That's not correct. Sorry, equation 1 is the black one. And let's call point B over here then. Let's make point B there, okay? And that actually would be 1, comma 0. Sorry, 1, comma 0. So let's plug it in. So we're going to get, I'll use black for that line. So we know the line is supposed to be x minus 2y equals -4. So 1 minus 2 times 0 equals -4. It's already looking not so hot. So that'd be 1 equals -4. And unless you're really tired, that should not make any sense. So that's, once again, sad. So what I know is equation 1 cannot be that. That line in red that we've written down. Okay, so let's try the green one now. Okay, so the green one, and we'll try point C, and that's the x-intercept of line where it goes through there, which looks like -1, comma 0. And if I plug the numbers in, I'm going to get x value is -1 minus 2 times 0. Already not having a good feeling about this one. -1 equals -4. So once again, that is incorrect. So this one's incorrect. This one's incorrect. And wouldn't you know it, I would always pick the last one to maybe be the one that's right. So this is point D here. Okay, so we're going to look at line 3, and we're going to look at point D. And point D is -4, comma 0. So plugging it in, -4 minus 2 times 0 equals -4. So -4 is equal to -4. So that is pretty sexy. So that does work really nice for us. So what that means is that the purple graph goes through the y-intercept of 2 and an x-intercept of -4, and actually satisfies the equation what x minus 2y equals -4. And once again, if you picked another point that's on the purple line, it would have worked for you. So what we would say is line 3. See, I'll use purple here. Line 3 is the equation x minus 2y equals -4. Now, once again, this is a thing we're gonna be testing you on, is can you plug points in, and does it actually agree with the equation that's given here? However, if you wanted to unravel this thing and you just kind of, I'm going to skip a few steps here, but we've done this in other videos. This would be -2y equals -x minus 4 divided by -2. So y is equal to 1/2 x plus 2. Okay, and so you can see on the graph the y-intercept is 2 and the slope is definitely 1/2 then. Well, within reason. I think I drew it pretty quickly here. Okay, so moving on to our last little example here, is let's say you are given a line. Okay, so I'm going to draw a line, and we actually did this in an earlier video, but I thought it would be worth reviewing because I can see how this thing we're going to do right now can be a little trickier for students. Okay, it's a lot more algebraic, and in grade, remember algebra, so we need to use a little bit of math from Persia, and take a look at our line. And someone says to you, well, what is the equation of this line? Like, what would the equation be that produces this line here? And so generally, if you're looking at a line, you really need 2 points to answer that kind of question, okay? Now, once again, I'm looking at the graph. It looks like it goes through maybe it goes through -1. And in fact, I'm gonna change it. Let's get rid of that. Let's make sure it looks even more not so clear. Okay, so let's do this here. There we go. That should do it for us. Yeah, it's a little more uncertain maybe. There we go. Let's do that. So if you're trying to write the equation for a line, you do need to have, generally you need to have 2 points if you're working off a graph. And so let's write down the coordinates of the 2 points. So let's call this point A. Use a different color to make it more exciting, and make this point B. Okay, so point A, coordinates of point A would be 1, 2, 3, so -3 on the x, and go up 1. And point B would be 1, 2, 3, and we're down at 1, 2, 3, 4, -4. Okay, so there's our 2 points. I'm just going to verify it again. So 3, -4, and 3, 1. -3, 1. Okay, so we're writing the equation for a line. So let's take a look at a line. Y equals mx plus b. Okay, so generally we know now that the m is the slope and the b is the y-intercept. And the y-intercept is not easily recognized here, so I'm going to leave that out. And let's find our slope here. Okay, so slope. Once again, for many of you guys, I know you guys are awesome students. Many of you guys, I can see you in physics 11 and 12, and chemistry 11 and 12, and maybe even math 11 and 12. And knowing how to figure out the slope of a line is like so important in those courses. So I'm going to spend a bit more time reviewing that with you. So in those kind of courses, your teacher will probably show you something like delta y over delta x. And that's really the same thing as rise. Remember, rise is the y values going up and down the y-axis, and run would be along the x value here. And then this weird symbol, it looks like I'm saying triangle y. It stands for a term called delta, and delta means change in. She does mean that. So delta means change in. So we're looking at the change in y, which is y2 minus y1, all over x2 minus x1. And if we work out that value, I'm going to make this x1, y1, x2, y2. So let's try that. -4. Actually, before I go any further, what do you guys think about that line? Do you think it has a positive slope or a negative slope? What do you guys think? And what about the y-intercept? Do you think it's a positive y-intercept or a negative y-intercept? So it's good to ask those questions before you jump into these things, so that you can sort of go, oh yeah, that kind of makes sense to me. Okay, so then I'm going to do x2, which is 3, minus -3. Okay, so -4 minus 1 is -5, and 3 minus -3 is really 3 plus 3, which is 6. So do you agree with that? Does it look like a negative slope to you? Well, let's figure out. If you were at A, you'd be going down 1, 2, 3, 4, 5. That's your -5. And you'd be going over 1, 2, 3, 4, 5, 6. So it is down 5, right 6. Okay, so let's hope that kind of makes sense there. Okay, so I now know for my equation of my line is y is equal to -5 over 6x plus the b value, which is the y-intercept. So let's find the y-intercept now. Now, once again, in order to do that, you got to have a point on the line that you can work with. So you could choose a third point if you wanted to, but why bother doing that? Why not work with either A or B? It doesn't really matter which one you pick here, because they both each have a negative sign with it. I said in an earlier video, it's always better to pick ones that don't have negative signs, just the math makes it a bit easier for you, but I don't think you can get around that. So since I have a choice here, what I might choose, I mean, if I make the x negative, I know when I times a negative, it's a positive, so maybe that's a good thing. If I make the y negative, then I'm just dealing with y being negative. So there's lots of advantages to choosing either or. I'm going to pick point A though, but once again, if you pick point B, you will get the same answer as long as I don't botch the question. And if you look at the diagram, it looks like to me it's going through something like -1.6 or 1.7. So I got an idea roughly where it is. But let's plug the numbers in. Okay, so I'm going to plug in a y value of 1. And that's supposed to equal -5 over 6 multiplied by x. And the x value is -3. So I'm going to turn that into -3 over 1. Okay, plus the b value. Okay, so I know it's 1 equals, now a negative times a negative is a positive, so I'm just going to get rid of the negative signs right now. And you could write that as 15 over 6. But I'm going to be a little little sort of work, make my math a bit easier here. I'm going to say 3 goes into itself once, and 3 goes into 6 twice. So this would be 5 over 6 plus the b value. Okay. Now, once again, you could subtract 5 over 6 from both sides, but I'm going to do that little shortcut where I times everything by 6, multiplying by the LCD. I'm going to bust out those fractions, okay? So timesing everything by 6. So this side would be 6. This would equal 5 plus 6b, okay? So let me just check that. Yep, okay. Now, when I bring over the 5, sorry guys, I had my my kids asking me a question there, and I realized I shouldn't be doing two things at once here. Sorry. So let's go back there a bit. Remember I said that I reduced it down to a 2 here, which meant it should have actually been a 2 on the bottom. Okay, because it would have been 15 over 6, which we'd reduce down to 5 over 2. So my LCD is actually 2 here. So I'm going to times both sides by 2, not by 6. So that would give me a 2 equals 5 plus 2b. Okay, now I bring the 5 over by subtracting 5 from both sides. So that would give me -3 is equal to 2b, or not 2b, and divide by 2. So now I get a b value equal to -3 over 2. So -1.5 approximately. So my drawing's a little bit off because I'm human. But according to the 2 points, the y-intercept should be going through -1.5 here. Okay, so what's the equation of the line? Well, the equation of the line is y equals mx plus b. So my m value was there. That's my m value. That's my slope. And my b value is there. Okay, so I just plug the numbers in and I'm off to the races. Y is equal to -3 over 2x. Oh my goodness. -5 over 6. Let's try that. -5 over 6. So -5 over 6 is the slope. -5 over 6x, and then -3 over 2. So pretty ugly looking equation there, but I hope that helps. So anyway, I'm going to sign off here. I hope you guys have a great weekend, and we will talk to you soon.